So I'm not sure if this has been done before. It must have been, but Karina and I were chatting the other day, and we kind of both realized that we each knew something about one of the frameworks and absolutely nothing about the other. So we thought, let's make a show out of it. So here we are. I've been doing LabVIEW for a long time, I think 25 years or so, and I've seen a lot of things along the way, but Active Framework is one of those things that I came across, around the time it started to go public, and it kind of changed my life in a way, or changed the way I saw application development. So I thought it would be interesting to share some of that revelation with you guys. And
I'm Karina Taylor. You've heard of me already today because I work with Paul at the university. I also have my own company, Envisenge, which is an NI alliance partner. And so I spend a lot of time working on my own, and I get a bit lonely. So I like to, make teams with people and do things as a team. So I've actually known Chris and worked with Chris in the LabVIEW world on and off in a lot of different jobs for, I guess, more than 20 years. So yeah, it's been a really good discussion that we've had coming up with this presentation. So yeah, that's right. Yeah, because we're not very old. Yeah, so we hope that you, I guess, get as much out of this presentation as we've had with our discussion so far.
Okay, so who has used DQMH to some level, knows a little bit about it? Yeah. Okay, and what about Active Framework?
It is split. Oh, no.
And how many people have done quite a bit of both? No one? Okay, good. Because I was going to say this is not really for you. This is not intended to be a deep dive. You're not going to sort of learn all the really kind of exotic skills that you need to make amazing applications in either framework. This is intended to kind of give you some context for how each framework is similar and different, and why the similarities, which generally apply to many frameworks, are actually useful, and why the differences might make one or the other choice better or worse for you. So we're going to look at some concepts. We're going to code up, well, we've got pre-coded an application built doing the same thing written in each in each framework. So you'll see how you approach a very simple application using one extreme class-based architecture or a nice code-heavy DQMH version. And totally objective. We are, of course, we've picked our sides already, and now it's up to you guys to choose.
All right, so just a word that Chris said was simple. We're going to approach this presentation, or this fight as it were, with a very, very simple application which has all the little pieces that you pretty much have in every DAC application ever. But we wanted to just choose something very simple that we can then demonstrate and walk you through in each framework, but with the same set of requirements and the same application. So I'm just going to explain what it is that we're trying to do today in each framework so that you can see each outcome and how each one is built along the way. So let's assume that we have a project requirement to create a data acquisition system, but we want to deploy phase one of the system at some point in time, and then we will add on some extra features later along the way when the budget increases or whatever it is. So phase one, we need to acquire a signal. We need to present that signal on a user interface. We need the user to be able to start and stop that acquisition, but every time they start the acquisition, they should be able to set the acquisition settings. So it might be the sample rate in the real world, but in our case, it's going to be, say, the amplitude and the frequency of the signal that we're going to simulate. And then we, of course, want to save that raw data to file. In the future, we want to add some analysis to that project, and we want to save the analysed data to file as well. Now, this could be written in probably a single VI. So for the purposes of today and for our discussions, let's consider that we have a few constraints, that we have multiple developers working on this project, where we have a different person working on the user interface, a different person developing the analysis, maybe it's really complicated and tricky, a different person working on the logging, and a different person working with the hardware because it's off-site and the whole team can't access it. So that's the reason why we need to create separate modules for our application.
Okay, so the easy way to get started, which, you know, the way that many of you would have started this at some point in your lives, is a producer-consumer. It's very standard, everyone understands it. You learn it early on in your LabVIEW career. The core of a producer-consumer is really the message handling loop. And that's convenient because that's really where DQMH and Active Framework are the most similar in some sense, that you've got this entity somewhere in your project that's handling messages or requests. And then producer consumer, you've got, like, you know, the messages could be coming from an external loop, like an event structure or a helper loop or anywhere else. But the heart of the system is this consumer loop, which is where all the actual work is generally happening. So you could take this design and you could use this to solve the technical problem, the system we're trying to implement, and you may need to add multiple loops to handle things, you know, in a concurrent fashion. So you can have acquisition running at a certain data rate in one loop. You might have some analysis, which is running in a kind of a pipeline fashion in another loop. You could have logging happening and, you know, disk is a bit flaky, so you want to do that in another loop so you don't block the system. So you might end up with this multi-loop producer-consumer style design. There are some issues with this. It doesn't scale that well. So if you're talking about breaking this apart and having multiple developers working on different components, it's very difficult with a VVI kind of approach. So the first thing you think is, well, how can we make this modular? And, you know, other things with producer consumer, this happens, I mean, I think this is why frameworks exist in LabVIEW. People tend to solve the same problems all the time. Oh, I want to stop the application from the user interface, but I've got all these loops running. How do I stop all the loops? This one's still busy. This one is, you know, doing something else. How do I synchronize activity within my little application in a meaningful way? So frameworks aim to solve a lot of these issues for you. They take a lot of the kind of boilerplate stuff and do it as automatically and in a sort of a certified, guaranteed way that someone has thought long and hard about, so you don't have to.
Yeah. So as Chris mentioned, the producer-consumer is a good starting point. But why do we use frameworks at all? We don't want to reinvent the wheel. So as we're using producer-consumers and so forth, we end up finding that we're coding all these common bits over and over again, and we can code bugs into them. And we don't want to have to do that over and over again. A framework allows you to just kind of take that template and reuse it. A framework also imposes structure. So whatever framework you choose, it means that all the developers using that framework are going to have a similar coding style, and you'll all be able to understand each other's code once you've learned how to use that framework. The other thing, and Chris mentioned it, is that any common code is proven. Once you've got some confidence in that framework, you don't have to keep retesting the messages or the loop speeds and things like that, because you just build on that same framework and you know that that is already solid and it works well. And that can work when you need to do re-verification and things like that. There's parts of the code that you don't need to re-verify. But that's frameworks in general. So why did we choose to talk about Active Framework and DQMH? I guess they're both designed to solve the similar issues that we can face in certain applications. So a lot of times we come up across applications that require asynchronous processes. So they require things to be done over here. This guy's doing one thing, this guy's doing another thing. And Both Actor Framework and DQMH do that very well. They both have these different modules that are doing their own thing, that have messaging systems to be able to communicate between those asynchronous processes. They both include wizards to help you code the framework stuff, so you don't spend all of your days writing queues and messages and things that we all used to do 15 years ago, that took all of our time, and the actual guts of it took, 10% of the time. And of course, they both encourage the design of modular, reusable building blocks that we can use over and over in different projects, so long as we design the code properly in the first place. Oh, over to me. You can take a seat, maybe.
Yeah.
All right. So I'm going to be a while. So a lot of you here, I feel a bit silly actually. We decided to talk about DQMH and Actor Framework before I knew that the queen of DQMH was going to be here and giving courses to half of the people that are here. So what you've learnt yesterday, if you were in the intro to DQMH with Fabiola yesterday, is probably a lot deeper than what I'm going to go in the next 10 minutes. But I just want to show the main concepts, give you a review, and then compare that to the main concepts of Actor Framework. So what is DQMH? It is an asynchronous message-based framework developed by Fabiola Della Cueva and her company Delacorp, but it is now maintained by the DQMH consortium. It is a free installation downloaded via VI Package Manager, so it's really kind of quick and easy to install, and we don't have to pay anything, so we're eternally thankful unless we help out and become trusted advisors. And one of the beauties I find of it is that it's accessible to CLD level programmers. So you don't need to have a team of CLA level programmers. You can have medium level programmers working on a DQMH project, and they should be able to understand most of what's going on there. So for me, to simplify DQMH down as far as possible, it has two main concepts. A module, which is an asynchronous process, and it's based on a queued message handler that lives within a VI library, or a LabVIEW library. The communications that occur between those modules are called events in DQMH, and they're built upon LabVIEW user events. So there's two main types of events, and there's sub-events below that, some newer than others. But the main two types of events that you can have are request events, where you basically ask one of the modules, a process, to do something. It's a command. You say, please go and acquire some data. Please go and log this data. The other type of event is a broadcast event, and that allows you to broadcast to anyone who cares, any other module who cares, or any other piece of code that cares, that something has happened. So we usually think about broadcast events being past tense, something already did happen, and request events being more of a command to ask a module to perform some operation. Yell out with any questions if you have them, and Fabiola will answer them. So in terms of our application that we're going to tackle with DQMH, this is how conceptually you would map from a standard producer-consumer into DQMH. I have chosen in this example to just use a standalone VI as the user interface. It won't be a DQMH module. A lot of people choose to use a DQMH module as their user interface. It's kind of a controversial point of discussion, and I think it depends on the application and the programmer. But in this case, I just wanted a really simple user interface, so it will have an event structure and it will communicate with DQMH modules. So I therefore have a DQMH module for my acquisition loop, my analysis loop, and my logging loop. So I'll have 3 different DQMH modules. Each of those modules will be a LabVIEW library with a whole bunch of VIs, supporting VIs, and then a main VI, which is basically the queued message handler that runs the main brains of the DQMH module. Looking at a DQMH module in the project structure. It looks a bit scary. There's a whole lot of VIs, and this is kind of what Chris is talking about. There's a lot of code here. So every time you go and create a new DQMH module, you will get automatically a LabVIEW library and a whole bunch of VIs underneath that. So literally this screenshot I got by opening a new project in LabVIEW and saying tools create new module. You can see the module is called module and the project is unsaved. So it was literally a few clicks. So we get all of these VIs. Under the library, we have a public API. And this is a folder where we can find all of the VIs that we can use from outside of our module to tell the module to do things or to subscribe to the module's broadcast events. Then we have a bunch of private stuff, broadcasts, requests, private module sync. We just tend to ignore those if we're not getting too heavy into the DQMH programming. And at the bottom there, we have our main VI. You'll notice that that's also private, and that's basically to encourage interaction with the module from the public API rather than interacting with it from the external world in other ways. You don't call it as a sub-VI or anything like that. One of the beautiful things about DQMH is that when I create that DQMH module, which in this case is called module, I also get an API tester. And so this allows you to exercise all of the request and broadcast events within your module as a standalone tester. And you can also use it as a sniffer as you're running the code. So it's a very cool thing to have as you go, to be building this tester that proves whether your code is working or not as you go. So the main VI, when you open that up, you jump into the block diagram and it's basically a QMH, and we can all understand that pretty quickly. So we have generally an event handling loop or the producer, and the messages come in there from the outside world, from the public API, and then they get passed down via the queue to the message handling loop, and that's where we do or code up our functionality. There is some class-based programming in here to deal with the messages, and Delica has already dealt with all of that and put it in the VI lib, so we don't have to go in there and deal with any OO. All right, so going back to our application that we're going to try and solve today using DQMH and AF, this is my kind of block diagram design of how we're going to solve that problem. So we're going to have a user interface, and for phase one, we only have an acquisition module and a logging module. So we have a little legend over the side. So the blue or the navy arrows are request events, and the yellow arrows are broadcast events. So our acquisition module will have two request events, so two things that it can do when you ask it, and it's to start acquiring and to stop acquiring. And when you do start acquiring, we're going to send it what frequency and amplitude sine wave that we want to create with that acquisition module, because it's a simulation module right now. Whenever the acquisition module has acquired its data, it is going to broadcast that to whoever cares, but our user interface is going to be subscribed to that message and know when new data has been acquired, and it will be able to show that on its user interface. And so the argument for that is a waveform. We're also going to have a logging module, and it will have 3 request events: to open a new file, in which case we need to give it the file path, to close the file, and to log a waveform, and we give it that waveform. I don't have, well, I've chosen in this case not to create any broadcast events. It's probably good practice to say I did log, I did close, and so on, but we want to make this application as simple as humanly possible for this presentation, so we're just using minimal events here. So then I deploy this system to the field, and then they want the extra modules to be built in later. So we have the analysis module, and here it's just basically implementing a low-pass filter, and to do that we need to give it the waveform that we want it to filter, and the cutoff frequency. So that's one request event that we're going to use. And then it will have a broadcast event to say, I did analyze the data and this is the filtered data. So there's also a few other design decisions here. I could have had this broadcast event from the acquisition module captured by the analysis module, but that would kind of create some interdependencies that I chose to keep all of the dependencies or all the messages coming through the user interface. So that keeps the modules more standalone. And these are some of the design decisions that you do have to make along the way. Also for phase 2, we need to log the analyzed data, the filtered data. So for our second logger, another awesome feature of DQMH is I can just create a clonable module instead of a singleton. So when I first create my logging module, I'm going to say I might need to log some other waveforms because I know that phase 2 is going to need to do that. So I create a clonable module, and now I have automatically a second logger with the same request events that I had for my first. I just send different arguments to it. So I don't really have to do anything for that second logger. Sense? All right, so here's where all the things go wrong. I have very limited room here, so this is going to be interesting. Anyway, I'm going live, like it's terrifying, right? It's not a video. Okay, so firstly, I'm just going to show you the phase 1 code, and then we might try and add in the phase 2 code. See how that rolls. All right, so this is my DQMH project, and under my modules folder, and this all happens automatically with DQMH and the wizards behind it and all the scripting, I have my acquisition module and my logging module. And then I have my testers in a folder down here. And I have my user interface, which is not a DQMH module. I've just chosen to use an event handler, a user interface event handler. So let's jump into the logger first, because that's like really simple. So I can see there's a main VI, and it doesn't have much on the user interface. This is how they come straight out of the box when I create a new module. And in the block diagram, which hopefully you can see, I have all these user events that are already included. So show panel, hide panel, show diagram, stop module, get execution status. That already comes pre-coded for us with a new DQMH module. But we do have a couple of new events which I coded in. So there's the open file, close file, and log request events for the logger. That was it. So let's say someone calls the open file request event. This event structure gets fired, and one thing that is, well, that you don't see all the time, that is particular to the clonable module is this little VI here, which is saying, is this actually addressed to this instance, my instance of this logger, or not? And if it is addressed to me, then I'll go and throw the message down to the log waveform case. If it's not addressed to me, I'll do nothing. So in the open file case, I get my file path that was passed in as an argument to my request event and just open a TDMS file and throw the reference into the state data of that DQMH module. So I've tried to keep it really simple. Similarly, we have a log waveform where I just log the incoming waveform to that TDMS file, and a close file where I just close the file. So it's pretty simple stuff. All right, if I open my acquisition module, pretty similar. There will be a difference. So this guy has 3 loops. So something that was added more recently in DQMH is the ability to have a helper loop. And a helper loop is something that allows you to perform a repetitive or processor intensive piece of code that doesn't kind of block your QMH from doing other business-like tasks. So it's perfect for acquisition. So in this case, we have the event handling loop, the message handling loop, and our acquisition helper loop. So let's just look at the start acquiring case. We catch the start acquiring request event here, and we have our frequency and amplitude coming in. I pass that down to the message handling loop, and all I'm doing here is triggering another request event, but this is a private request, so it's only accessible from within this module. And all it's doing is waking up the helper loop. And as one of the choices in the scripting for DQMH, I just get to say, this is a private event and which loop is actually going to listen to that event. So it's only being listened to from my helper loop. So when I initialize my code, when my code starts, when my module starts, the original timeout for this helper loop is -1. So this loop is sitting here asleep, doing nothing. When I get the wake up acquisition loop private request, I set the timeout to 100 in this case because we're simulating the data acquisition. So probably in a real acquisition project, I would set that to 0 or 1 so that my data acquisition would define the loop rate of my code. But in this case, I'm setting it to 100, so this loop will execute every 100 milliseconds. I'm also just passing my frequency and amplitude through to the state data on that loop. So now the timeout is actually running every 100 milliseconds. So I'm generating my noisy sine wave and I'm plonking it into my broadcast event VI to send it out to whoever cares. So that's just how my acquisition code works. In terms of the user interface, this is what we kind of built here. The filter cutoff, I'll show you the block diagram. So we just have a really simple state machine with an event case in the sort of user state. So my 3 states are initialize, user, and exit. So in init, I start all my modules and I register for the broadcast events that I'm interested in. So I'm only interested in the acquisition, well, I'm interested in all of them, the acquisition and the logging broadcast events. So now I have that dynamic event reference that I can subscribe to in my event structure. I also just wait for all of those events to be valid. This is one of the things you do to launch a DQMH module. Once we're in the user event, I just wait for button clicks, really. So to start the acquisition, I will have an open file on 2 of my loggers. I've already put my second logger in here to cheat. So my first logger, let's go back to init. Never mind. I initialize these 2 modules with an ID of 0 because they're clonable modules. They each have an ID and that is an address for which I say which logger I want to speak to at any time. So I open logger number 0 or number 1 with a file path as DQMH demo raw, and I open logger number 2 with a file path of DQMH demo analyzed. We don't have any analyzed data yet. And I say, please start acquiring with this frequency and amplitude that I send in from the user interface. We have a stop acquisition case where I just stop all of the loggers and I stop acquiring. And toggle module panels, and I use the DQMH modules or DQMH request events that we've already been given through scripting, show panel and hide panel, so I can show and hide the user interfaces. That way, that's pretty much it. Obviously, we're also subscribing to the acquisition modules broadcast event that data has been acquired. So when that happens, this event case gets triggered and I will just write my raw data to log waveform, so send that off to the logging module, and it's the first element, so the first logging module, and I'm just going to display that in the first element of my graph display here too. So that should all.
Just one thing you didn't point out for.
Aha, yes. So if you've got a clonable module, where was that in stop? Instead of having to write a for loop with all of the IDs, module IDs going in, I can use a -1 and that just says address this to every single module. Yeah. Okay, so in theory, this should all run. So nothing happens until I press acquire. I now have a 100 hertz signal, amplitude 8, and I can start and stop that. I can change that amplitude. And remember, we sent the amplitude and the frequency in at the acquire phase, so that's not kind of a dynamic variable that we can change during the acquisition. And you probably saw all these TDMS files get written to my desktop as well when I started the first acquisition. So how then would we create some DQMH modules to add to this project? So I'm just going to really quick, like, what I love about DQMH is it's so quick and so easy. So I wanted to just show this live, which is, yes, terrifying, fraught with danger, but let's roll. So we're just gonna go to Tools, DQMH. We need a new module. So we're first going to build so already the logging module is clonable, so that's already built. So what I really need to do is just build the analysis module with the filter request event. And that filter request event will need to have my waveform and my cutoff being sent in. Can't see the keyboard, so analysis. So what I do here is I name the module and I give it a VI icon and I check everything is okay. It's a singleton, it's not clonable. It goes into all the default locations and I press OK and all the magic happens in the background. And instead of me coding for all day to try and get this module and all of its messages happening, just does that while I go and boil the kettle. So we have our analysis module here and main VI. So what we need to do is add the request event, that is to filter. So we're going to add an event. And first we need to select a module, which is going to be our analysis. So whatever modules are in my project will pop up here. It needs to be a request event, and I said there was a few other types, but request and broadcast are kind of like the main types. It's going to be a public request so that people outside of my module can access it. And I don't have any helper loops or anything, so it is going to be caught by the event handling loop, and we're going to call this filter. Now, in order to be able to send data into my module with that request event, I need a cutoff. And a waveform. And then I can press OK. So, Descriptions. I should write descriptions? Yeah. Do you want to watch me write descriptions? No, you don't. Not while I'm nervous as well. No, that's right. It'll tell me it's not good. Okay, so I noticed this morning Fab said, we make this API tester pop up in your face, so you must code the API tester. Look what just happened. My tester popped up and said, code me. So I have my filter button here. And so this is the block diagram of the API tester. This is not actually my module. This is the standalone tester that tests my module. So here's my filter button. I have my analysis request event VI, that is the public VI I call to ask my analysis module to do something. And I pass in a waveform and a cutoff frequency. So I'm going to need on my user interface, my filter button already gets created for me. And I need, I don't know, I'm just going to be ugly, a cutoff. And I want to have some graphs here. I want my raw data, and I'm eventually going to want my analyzed data. Cool, so that's pretty much what I need here. So I'm going to delete my description or my pass my cutoff in, and I'm just going to do an express simulate whatever, noisy sine wave, so that I can test my analysis module. So I pass that in. So that is now coded. So when I press the filter button, I can send in my cutoff and basically asking the module to do something there. Then I can go to my DQMH module, which also popped up and said, I've created your event to catch my filter request. So what do you want to do here? So all I need to do here is throw in, I'm just using Express VIs because they're awesome for teaching and for doing things super quick, but where am I going? Analysis filter. And we'll just use the default settings and throw in the waveform and the cutoff frequency. And we should wire up all our errors and things like that, but never mind. All right. We save everything. So that's our request event. The only other thing we need there is our... I will. We need a broadcast event. So we also need one more event for that module. We need to send the analyzed data back to our main application or whoever cares. So analysis, this time we're going for a broadcast event. And this is data was filtered. And then I write in the description, Chris, and my argument is my waveform. Cool, go. Let's hope. Tester pops up and says, fill me in. So what happens when my module broadcasts something that my tester has already been scripted with, please catch this. And so I need to basically do something with the data that it just sent. So I created my second waveform graph, and I'll code that in with the new data. And I'm just going to say response received. That'll do. You'd usually do better. Okay, so my tester should work. I'm just going to save that and move that over there. And you can see on my main VI, all it's done is given me this broadcast VI that I can stick anywhere I want to say data has been filtered, but I need to wire in my filtered data and wire up your error wires and so on. Okay, so this is where magic happens and we can run the tester and see that everything works. Is it going to work, Fab? Oh, let's hope. Okay.
Your demo is live.
It's never going to work. So we start the module and it did start, so that's good. We show the module panel, we can hide the module panel, we can show the block diagram for troubleshooting. Now, I just wrote this code, right? But we've got all of these features where we can jump in and debug and do all sorts of things. I'm going to cut off not at a frequency of 0, maybe 20. And I'm going to press filter and it doesn't work. I should have got my raw data on one graph. I didn't wire it up.
I wondered, we were going to say something.
Oh, thanks. Thanks.
That's why you test.
Exactly. I didn't wire it up in the module.
No, in your tester.
In my tester. Oh, I didn't. I just left it. Okay, yep. Look at that. Give me a break. Look at that. So there's my waveform 2, and it's going to waveform graph 2.
I just thought it was part of the process.
Yeah, well, see, I tested it. It was wrong. I didn't have enough coffee. So let's just, again, change the cutoff and filter, and we have our raw data going in and our filtered data coming back. Hooray, our module works. Hooray. So I was going to maybe code up a user interface, but I took too long. So I am going to... Yeah, I know, right? Telling me... So luckily I baked one earlier. And let's get rid of this one. So this guy has acquisition analysis logger. I did exactly the same things in my analysis module, but in the GUI here, I have now my third module. So all I did was add my analysis start and stop to the init using the public API of the new analysis module. I catch the data filtered broadcast event and I throw it in element number 1 of the display. I start the acquisition the same way. I stop the acquisition the same way. I show and hide an extra panel. And here, when I get my data acquired, user event, so after the acquisition module has acquired data, it sends it to the user interface here. And this guy says, okay, log it, but also send it off to my analysis module to be filtered, and then I catch it later. So now, when I run my code, I should be able to acquire, and I get my filtered data. And this should be changeable on the fly, because every time new data comes in, I send it off to that analysis module. So that's kind of how we just plug it in using the public API. So that brings me to the end of the demo, and now Chris gets to observe some things about its
Well done.
DQMH.
Don't run away.
Oh, yes. Tell me all the things.
So, Karina, great work, but no, so look, this was, until like a month ago, I'd never used DQMH. I'd seen it here and there, and I'd seen, code, but I'd never used it. And Karina and I had a few sessions where we kind of went through each other's attempts to implement this little test project. And that's where I did all my learning. But this is maybe the best thing about DQMH, that I was able to learn conceptually what it's doing and how it's doing it very quickly and easily. So that's great. Highlights for me, I think the scripting is like a work of beauty. It's amazing to have the things that otherwise would take you a lot of repetitive time just handled for you. And so much so that I think any tool or framework or any product that you want to be successful in the broader community has to have really nicely polished tooling there to help you get the best of it. So the code is one thing, but anything that can help you to produce the code more efficiently pays for itself really fast. So hats off. I know scripting is painful to actually write, and maybe that's why you password protect it, because that's your remaining baby. But without scripting, you'd have a good product, but I think with the scripting, it's a great product. Unit testing and documentation and all these other add-ons are kind of in the same kettle. It's really nice to have all that stuff automatically incorporated into the project. Learning curve I mentioned, so really quick to get up and running, which is attractive for people who are on a timeline, which is all of us at some point in time. And I think the community is the other really, great feature about DQMH, that there's a growing body of people who are not just across it, but passionate about it. And that passion running through a group of people only helps. So I think as more people start to use this, it's sort of, the feedback is positive, and it means that when you need a problem solved, you're going to have people that are there to help you, which is in the spirit of LabVIEW, I think. The bad stuff, bad's the wrong word. The stuff that I found didn't work for me in terms of my coding style. You get a lot of code with the DQMH module. It's all there to see. A lot of it's hidden away in the private space, but even the public API is pretty heavy. And because each module is kind of standalone and generated like that for you, a lot of things are duplicated. So I'm used to more the object-oriented world, where if you do something 5 times, you just write a base method that captures all that stuff and roll it out 5 times, 5 instances. So that is one thing that I noticed. And the second thing is, again, probably kind of as a result of the scripting for one, and secondly, because this has to be accessible to people that aren't experts, there's a lot of comments and structure and extra stuff in there that makes it kind of busy. Now, I think when you first use DQMH, you're going to love all this stuff because it's like, oh, this is telling me exactly why this is here. And, you know, I can learn a lot from that. But maybe after a few weeks, you want to just hit mute on some of this stuff. And maybe that's a feature or...
You can create your own template.
There you go.
So... And then you can remove all my documentation.
90%. This was just a comment, maybe more than anything else. The last thing is a bit more subtle. So when I see a folder of public API methods that allow you to hook into any user event just by dropping a VI, I think, wow, someone's going to come along and sprinkle these user event references throughout their entire project and create dependency spaghetti. And, you know, you have to live with your own choices. But the fact that you can so easily create so many cross dependencies is probably something to watch out for if you're working on a large complex project as part of a team. So, you know, it's powerful and the obstacles to getting things done are really not there. You can do anything, but I would say that comes with, I don't know, what would you say? Like some caution. You've got to be careful. You need to kind of know the implications of some of your decisions.
Can I go now?
Yeah.
Great.
Yeah. All right. So I'm going to talk about Active Framework. When I first saw Active Framework, I was more intrigued by the idea of it because I sort of heard some murmurings that there was something there that was going to encourage really healthy programming style and this would solve everyone's problems. And I tried to play with it and thought, what is going on? Nothing made sense and it was really challenging for me. And because I'm a kind of tenacious person, I thought, no, I've got to figure this out. So I went through some kind of schooling and figured out some details. So I'm going to share from that viewpoint today. I don't know how many people here have gone through the same process where you peek a little bit at some Active Framework code and think, I don't get it. This is not for me. But we're hopefully going to just get below that initial landing point and look at what's really going on. So it ships with LabVIEW. It's built in. You don't have to do anything to use it. And you can pick up another AF project and it'll just run. So I gave my demo code to Karina. She just put it on her laptop and it just opens and works. Nothing to install. That's nice. It came as kind of a pet project. So Stephen Mercer, does anyone, Aristus Q on the forums, he gets around a bit. I think it might have been Alan who originally started looking into actors. Alan C. Smith, is that right?
No,
Maybe. But this was like Stephen's baby for a long time.
Alan was
Okay.
the first developer.
Yeah.
So he was the one willing to use the first version of Active Framework on a customer.
Yeah.
I think he
Courageous.
recommended
Yeah.
that.
He took a lot of arrows.
Yeah, he took all the arrows and all the hatchets.
Yeah. So anyway, Stephen really went to town on this project and poured a lot of his heart and soul into it. And I think there's some really good stuff in there if you're willing to kind of take a deep dive, but we're not going to do that today. Where it's come over the years is quite amazing. Now it's been open sourced. So essentially the code is now, it's always been available, but the next sort of generation of Active Framework will be having people from the community working on making it better.
It was originally open source. Then it was pulled into the product, and now it's open source.
Yeah. So pulled into the product is where I came on board, I guess. 2012.
Originally
Yeah.
it was open source, and
there were other. So originally, Actor Framework was open source. It was not part of. It didn't ship with LabVIEW. It was Stephen Loftus-Mercer, Alan Smith, and I'm forgetting the name of the other gentleman that was also a customer, and they all were working on the open source version of it. It's Stephen's baby because he's the computer science guy behind Actor Framework. So, and then it was put into the product, and now it's open source, and it's still going to be shipping with the product.
All that it means to say it's open source is that effectively from an NI mindset, where we previously had the source code to Actor Framework inside of our walls, and if somebody took it and did their own thing, like more power to you. Now, effectively, the GitHub repo is the source. So anything that gets committed to the main repo on the public GitHub repo is basically going to be in the next release of LabVIEW. So it just increases the agency of the community to do bug fixes and improvements that will then go back into the product that we sell and ship.
Yeah,
that's the philosophical change. I mean, I agree with that, but let's let him get on with this presentation.
So the open source thing is interesting. I do have some questions in my mind about breaking changes and things like that, because if people are depending on this code and rolling it out in many projects, there's a limit to how many things you can sneak in before you start actually structurally changing the framework. But anyway, digress. So who's it for? I would say it's CLA level, really. It's heavy on classes. So you really need to have a good object-oriented mindset or at least a willingness to go down the rabbit hole there to get good value out of it. And I'd say if you're building large projects where you need to structure things before they get really out of hand, or you have multiple people working on projects and you need to be able to speak a common language to get things done, then this is a good framework for you. And the style implications are pretty strong. So the nature of the framework is it's kind of very much imposing a certain style on the structure of an actor and the intercommunication between actors. And those things may not sound like much, but they really drive the style of a project. So no matter who develops the actors, the consistency in the interfacing is so strong that people can quite easily pick up other people's actors once you're initiated, you know? So a few concepts. What's an actor? It's just a process, like a VI could be an asynchronous process. Think of lots of things happening in parallel. An actor is one such thing that's happening in parallel with other such things. The way it's implemented is you've got all of the boilerplate code, like how do you launch an actor? How do you manage the communication? All this stuff is built into a base class called actor, LV class. And every actor you build gets all that stuff for free, which is nice. So when you make a new actor, you get an empty class. It doesn't look like there's anything there, but it inherits all these superpowers from its parent. The next big concept is a message. So the messaging is about how actors communicate between each other. And it's just based on cues. So when you know that, there's nothing really fancy about it. Cues are, by some argument, more accessible than user events, at least in the sense that when you start learning LabVIEW, you learn about cues. So conceptually, it's easy to understand that messages are just sending something from one place and picking it up at an endpoint. The messages in Actor Framework are the entire public interface to an actor. So everything you want to do with an actor, you do through messages. And this is like, you know, there are hacks around this. You can add all sorts of references and share them around. But basically, the guideline is that when you want to communicate with an actor, you do it through the messaging API. So any method or any capability of an actor, if you want to make that available to someone external, you wrap a message around it. And that's how people access that functionality. And then the messages themselves are packaged up in a library with the actor. So the actor is not really just the actor, it's the actor plus messages. That's the kind of entity that you're building. So messages are, I find it easy to think of them as a request because you can tell someone to do something. Really, you're asking. It may do it or it may not, depending on the state it's in. But when you're communicating with an actor, you're saying, please do this for me. You're being polite. Messages are also point to point. So we don't have a concept of broadcast like user events will provide. You can implement all this stuff on the side, but in terms of the framework, you get point to point messages. So the actor is the recipient of all the messages. You can send messages from anywhere, but they're all point to point. So the thing that really opened my eyes, my red pill maybe, was how an actor, the actor framework, is derived from basic building blocks. And this was the kind of thing that allowed me to understand really what's going on. So let's start with a queued message handler, which everyone knows about. There's some stuff going on in the case structure, and there's a message queue. You can hang other loops off there, so you can generate messages from elsewhere. You can have helper loops. You can do whatever you want, but the core of this is this message handling loop. So what we want to do, first of all, is for every command or message you want to send, like initialize, acquire, analyze, whatever you want this thing to do, you have a case structure. We all know this. So I've got init, acquire, stop. These are all some DAC events, whatever it is. Doesn't matter. Sometimes you might want to have some data associated with a message. So you say acquire, but give me 100 samples. Acquire with this frequency. And this is where a lot of standard message handlers get a little bit more complex because you need to start bundling data with the message itself. And people often do this. They'll have like a variant thrown in with their message. Where's my mouse? I don't know. There we go. Okay, so we've got a string and a variant. The ugly part of this situation is where the data is being used at the sort of receiving end, you then have this variant conversion and you have to hope you get the data type right. Oh yeah, so I am sending an integer there and that's going to be the number of samples. So I have to kind of handle this. Back to our basic structure. The first thing we're going to do is take our shared cluster, which kind of passes through every frame in our queued message handler, and turn that into a class. Let's just package that up. And what that gives us is a way to kind of hide away all the parameters. So I've got in there a DAC task and some data. I'm just going to chuck all that in the class. Beautiful. And then the second thing, which is what most of us really should be doing, but which many of us never do, is you take the contents of each case in your case structure and say, this is a bundle of code doing a specific task. I'm going to make that a sub-VI. So mostly we live with this, raw primitive calls and other things going on in cases, and that's okay. But for now, let's say we're going to be really, nice and clean and tidy and package the contents of each case into a VI. So I've got my acquire VI here. Notice I've left the handling of the input parameters outside. And there's the code inside that VI. It's all very simple at this point. I'm bundling and unbundling into the class wire. So the class wire is going to contain all the information that my actor needs to handle or deal with. The last thing we're going to do is replace our message with another class. So this idea of having a string and a variant, a command and some extra data, the one thing it misses is what type should that data be? So by turning this into a class, you can say, well, it can be any type. I can send an integer to this message, I can send nothing to the next message, and I can send a waveform and another cluster to a third message. It's all fine. So the class gives you extensibility. You'll notice that when I initialize the queue, I'm using some class here. This is my base message class, which is empty, it does nothing. But the new element that I enqueue, this init, I don't know if you can read it, this is a child class of message. So I have a specific type of message for every action that I want to be able to perform. In this case, I've got 3 cases in my case structure, initialize, acquire, and stop or something. So I would have 3 child messages for these things I want to do, which may or may not have data associated with them. The question is, what happens now when I want to send that message into my case structure? Well, again, classes to the rescue. The case structure becomes dynamic dispatch. So because your messages are all children of a kind of a message, you give them all the same method, do something, and then when each message gets dequeued, the do something happens inside that VI. So what you end up with, forget about this initial message that I'm enqueuing, but what we've really ended up with here is a loop that is simply dequeuing any incoming messages and then executing them. And if you do nothing more than add some error handling and a little bit of launching and a few other things, this is the core of actor framework. This is what an actor is. It's a loop that just sits there waiting for messages to come in and acting upon them. This wire can contain any of the possible messages that exist for this project. So the bad news is for those who like shoving all their code into one big case structure, you're going to have a lot of extra infrastructure coming along for the ride. So up the top here, I already mentioned that you're going to have a VI for acquire, init, uninit. But what you also get is one message class for each of these operations. So you can see I've got a base class called message up here that's got nothing in there really. And then a child class for acquire with a do VI, a child class for init with a do VI, and a child class for uninit with a do VI. They all have the same do VI because that's the thing that's going to do the work. And what does that do VI look like inside? It's calling, so the acquire message is calling the acquire method in the actor. So there's some sort of double handling there. The insightful people might see, well, you've got a lot of VIs and all you're doing is running this little piece of acquire code. Yeah, so this is where the weight comes in, like the heaviness in actor framework. The reason for this abstraction is you want the acquire method in the actor to have full access to the actor class input and output terminals. So the actor owns all of the internal data of the actor, and the acquire method then has access to all of that. So the messages are just providing an interface into that VI. And this is where you can do things like, I've given an example here where you're unbundling the number of samples per channel. So the message itself carries around any parameters that might go into the method, and it will send those in to the actor's method for doing the acquire. Okay. Again, this is like object-oriented 101, but actor framework looks on the, okay, so here we go. My actor on the left here. This is a brand new actor and it comes with nothing. There's nothing inside whatsoever, and yet it has some inherent capabilities. So how do you go about getting code into the actor? How do you make it do what you want it to do? The first thing to know is that there are these methods that already exist in the base class that ships with LabVIEW for doing these things. And here's my first gripe with Actor Framework. These names are nonsense. Sorry, Stephen, but they're really not obvious in terms of what they're doing, or maybe, I don't know. I think the naming is unfortunate, but once you know about what these methods, these overrides are doing, then you know how to use them. So another comment about Actor Framework, you kind of need to go to school and look at how the framework is built up in order to be able to use it. And some people might be surprised to hear me say that, or might even claim it's not true. But I believe it is true, because if you don't know the conditions that need to be met when the pre-launch init VI runs, you won't know how to use that. So stop core, what does stop core do? Well, it happens to be the VI that runs when the stop message gets sent to the actor. But that's not obvious. So you have to kind of go digging to know where these overrides are being triggered. And then what you see is if I need to do something on initialization, I don't have to write my own sort of big complicated VI to do that. I can just add that one thing I want to do inside the pre-launch init. And if I want to close some references, I can just do them in the uninit method. But, you know, not obvious. So this is where the learning curve kind of kicks in. The main one you want to know about is Actor Core. So Actor Core is the thing that embodies the main message handling loop of the Actor framework. So back to that derivation that I did, that all lives inside this single VI, which is the Actor Core of the base class. And then when you make an actor, you inherit from that class and you call the parent method. So here you have this little VI, which is a message handling loop. And then you can add your own code to that, which will run alongside. So you might add some initialization code on the diagram, some cleanup code. You might add helper loops, event handlers, whatever you want. Anything's possible. But the actual message handling loop is the thing that you don't need to touch. It just goes there sitting, handling messages for the duration of your program. So with all of that, how would I then structure my application? Same application as Karina. So we're doing that simple acquire a sine wave and filter it. Another comment about Actor Framework, you can't launch an actor directly. So launching has to be done by using a specific method and asking an actor to launch. So your top level actor of your application itself needs to be launched. So what people tend to have is some kind of throwaway VI that is the entry point to your application. I often make the launcher like a splash screen or something a little bit more visually interesting. So you've got an excuse for showing this thing on screen that's spinning up your root actor. In this case, my root actor is going to be the UI because that's where everything kind of comes together. I'm going to have an acquisition actor hanging off the side, and that acquisition actor itself is going to spawn a logger actor. So there's a kind of a tree emerging here, and this is another concept with Actor Framework. You want to arrange your actors in a kind of responsibility tree. So at the top of the tree is your root actor, and conceptually that will launch the things that it needs to directly manage or communicate with. And then those things in turn may launch other things which they want to directly manage or communicate with. So my main's launching my acquisition, which will in turn launch a logger. And in the future, we're going to do the same with analysis. The next comment here, I'm going to color code these and put some boxes around because the actor is not really just the message handling loop. As I mentioned before, the actor is also, it holds on to it owns all the messages that are associated with it. So here you see the main UI, it's not just the UI actor, but the display message, which is going to come from acquisition or analysis. This message is received by the UI. So it is the owner of the display message. And the same with acquisition, this owns the acquire message and the logger owns the log message. So the actor really is, each actor is sort of within the dotted lines, conceptually, you could say. I'm going to make 2 more changes just to demonstrate how this would work kind of for interest. I'm going to move my logger, my secondary logger, rather than be launched by my analysis, I'm going to launch that instead from the main UI. Now, why would I want to do this? One reason is the file that gets logged, I might want to manage that centrally. So I could have the main UI saying, create an analysis log called something, and tell the analysis actor what it should be called, and then tell it to create the logger. But in this case, what I want to do is initialize that secondary logger from the main, and then see how we would then integrate that into the analysis. And the last thing I'm going to do is my main UI, I've actually split that into like a 2-tiered actor, where I have an abstract user interface base class, which is packaging up a lot of the stuff I might want to reuse for other user interfaces, so that the actual main UI for this application becomes a little lighter and cleaner. So I'll show that in the demo. Are you ready? It's not going to be quite as courageous as Karina's demo. Hey. Okay, so here's a project. Each of these libraries is an actor. I've got my launcher. Let's start there because that's easy. I've called it launcher. And all this is doing is I'm dropping a class. Here's an object, which is my main actor. And the only thing this launcher is doing is just running the launch VI thing that ships with the actor framework. And this is where my application kicks off. So we'll start by running this, just make sure it works. I can acquire, yes. I can stop. I can probably change the frequency. There we go. And I can also start to do some analysis. There's a nice filter. Okay, beautiful. If I want to change the frequency, I need to stop again. So all the same functionality is there. Okay, so when I close this, magically everything is cleaned up. The cleanup is an interesting thing with Actor Framework. So as a developer, the easy way to use Actor Framework is if you take care of the launching, then the framework will take care of stopping everything for you. So all you have to do really is think about who needs to be in charge, who needs to also exist as an actor, and who should launch who and communicate with who. Once you get that clear in your mind, then the rest kind of falls into place fairly easily. So let's walk through it a little bit. My main VI, I get, oh, okay, I should show you how you get here first. This is as much of a live demo as you're getting. You can go for new. Is this, no, sorry. New actor. I mean, this is like baby scripting. It's not the beautiful, elegant, full-featured scripting of DQMH, but you know, it's something. Name of actor, test. Inherit from actor, okay. So what do I get? This sort of embarrassingly light, simple little thing that doesn't do anything. How I would then use this in practice, let's say I want my test VI to test something. I can put a VI in there. I'm going to save this. Could be anything. In fact, let me do it properly. Sorry. There's no script. Those who know me. Yeah, exactly. So let's get that guy. So here's a VI, I might want to do some stuff. I've got my class coming through. I'm not going to actually do anything, but let me just save this. So you start by implementing the functionality you want. And then once you have some functionality, then you can right click on here and active framework, create message. So this is, again, about the most interaction you really need to have to do 90% of the stuff you want to do. So I got a message here, do stuff message. I got a send method and this thing called do VI. Do VI, let's not go into why this is sort of so messy and everything, but all it's really doing.
Yeah, what's wrong with all the comments?
Yeah. It's not great, you know. I think if this was cleaner, it would be easier, but all it's doing really is just calling this method, which is my do stuff method. So this is the thing that will run inside the actor whenever someone sends this message. And the actual sending of the message, another VI has been made for me. Okay. This one is relatively simple, but this is the thing that you would use when you're trying to send stuff into the actor. Simple enough. So that's all you need to know. My main has a display message, and the display message has this send and the do, exactly like I just showed you. And the display method is already here inside my actor. So let's have a quick look through the main actor. I've got actor core. This is the thing that's going to show up as the UI. And what's going on in here? There's a whole lot of initialization. I'll talk through that a little bit. Then here is the call to the actual core queued message handling loop. And then I've got a user interface for handling button presses and so on. So start acquisition. This is using the send VI that sends the start request to the acquisition module. So back to the initialization, there's a few things I'm doing here. First, I'm writing some references to the class wire so I can access things on the front panel from inside sub VIs. Then I'm launching here the acquisition and disabled in case I wanted to do this live, but I'm not going to. This is where I'm launching the analysis actor. So this kind of yellow topped method, this is the standard launch method for the actor framework. When I launch the acquisition, it's not clicking that right. Okay. So here's the acquisition actor. Let's have a quick look in there first for context. So much like what Karina showed, I've got my message handling loop. I'm initializing, in this case, a user event, which I'm using to communicate with my acquisition loop. And the acquisition loop happens in the same way as the DQMH version that we saw in the previous demo. We've got a -1 on the timeout, so this sits here idle for a while. When we receive the acquire message, it's writing the frequency and amplitude into the cluster running through this case, and we're changing the timeout to something meaningful. I've used a start Boolean here. You could send a start or a stop and recycle the same method for doing the starting and the stopping. And then in the timeout case, it's sitting here acquiring a simulated signal, and it's sending it to two places. I've got two send VIs. One is sending to the logger, and the other is sending to the UI. So one thing that's worth pointing out is here's my UI again, which is my root actor. And when I launch the acquisition process, what I get back is the message queue of the thing I just launched. So when you launch something, you're given the keys to that thing. You can tell it to do whatever you want, including stop. which is happening inside the framework if you want it to. But in this case, this acquisition thing here, this is basically just a queue reference. And you'll see here, when I go to start the acquisition, I'm unbundling this acquisition queue, and I'm using that to send the message to that actor. The analysis I've done a little bit differently. So in this case, I'm launching two things. I'm launching the logger. Oh, okay, so again, I'll show you very quickly. In the acquisition, it's launching its own logger. So when I launch the logger, I've put that into a sub-VI. It's writing a file path into the class before it gets launched. So a class is just, it's like a cluster. You can add anything you want to the class and you can do stuff with it. So in this case, I'm putting a path in the object before I launch it, and that data will be preserved once I launch the actor, and it'll be sitting there. So the logger is getting the path, and then the thing that's doing the launching is, okay, here's a file, send that into the logger and launch it and get the logger reference back. And that same logger queue reference is the thing that I'm using when I send my data to the logger in the acquisition loop. Okay, clean up a little bit. So I mentioned that I wanted to do the acquisition and the analysis differently in terms of the logging. So rather than having the logger be owned by the analysis, you can also launch, in this case, the same logger actor, but with a different path and a different message queue is launched here in the main. And then I'm sending the message queue for the logger into the launcher for the analysis. So instead of writing a file path in, I'm now doing the same trick. I'm sending the message enqueuer of the logger in, just copying it to the class data when I launch the acquisition class, the analysis class. And then the analysis class, let's have a quick look in that one. Okay, the analysis class doesn't even have an actor core. It doesn't need one. So if you make an actor and don't give it any actor core, it's going to just run the base method message handler. So in this case, the analysis is like a kind of an interesting actor because it doesn't seem to do much. I've overridden this handle error override method. So this is something that you can do. The standard way of handling an error in Active Framework is just to stop. Don't announce anything, just stop. It leads to huge headaches for developers, but that's what you do, So actors just stop mysteriously. I've decided to handle the errors in here a little bit differently. I just don't stop. If an error occurs, I just keep going. And the only other thing really that my analysis does is I've got a filter VI, and this filter is the method that I want to do the filtering. It's exactly like what Karina showed. But you see in here, I know about the logger reference. So I can log data from my analysis actor that didn't even launch the logger, but I shared the address, the message queue of the logger with the analysis. So now it can use that message queue. So this is another sort of interesting comment about the Active Framework. You can share the message queues around far and wide, which is a bit like DQMH. You can drop these user event references. You can pepper them throughout your code. The difference maybe is within Active Framework, it's a little bit harder. You've got to work a bit harder to share the message queues around. So it probably forces you to think a little bit more before you do it. But the capability's there to be able to give anyone the ability to send a message to anyone else. Time. It's like really time. So I'm going to leave it there. I hope that was somewhat interesting or informative. We've got one more slide. If we can do this seamlessly. Kill us and then if you wish.
share.
Yeah. There we go.
All right. So I think Chris went through all of his own goods and bads. So that was really, really awesome. So the good things, I like that there's nothing to install and there's been much discussion going on in the front row about that. I also like that it's a really light project to start with because you inherit all of the code to start with. There's not much there. All the common code is in VI-lib. Like, you don't need to worry about it. There's not much to learn to ignore. In DQMH, you have to ignore a lot of stuff really as you get started. I'm a very impatient person. So for me, that learning curve is pretty steep, and I'm sure I'd be able to tackle it if I needed to, but I just haven't had that need just yet. So it's kind of off-putting for me, all the things that we need to learn, including what overrides we need to be able to use at certain points. I just really need to deep dive into it, where with DQMH, I can just kind of get going immediately. Even if I haven't looked at DQMH in a year and a half, I can build a project really quickly. To me also, the functionality just kind of looks disconnected. I can see all of the messages and the do-VIs, but they don't do much. I can't see very quickly an overview of who's talking to who or what the project is intended to do. I feel like it would need to come with very well thought out class names, so I knew what each message was trying to achieve, so that I could go to a place in my project based on its names to find the code that I'm looking to understand or update. And or it needs to come with some pretty serious documentation of what needs to happen. Comparing that with DQMH, I didn't show you, but you can run Antidoc, which is a free install on the project, and you will get this beautiful document in either PDF or HTML showing you all of the modules, all of the interactions, and kind of like flow diagrams of which modules are talking to which other modules. I can also see the full functionality in my main VI of a module, and I can see how to use that module using the tester. So also on that note, debugging looks really hard to me. I don't know where I'd even start. And sharing and delivering that code would need the documentation as well. But it does have its benefits.
Thank you. So there are some similarities, which is sort of interesting, even though they're quite different approaches to how to solve a problem. But the frameworks really deal with a lot of the same kind of things. So it's all about modular, cohesive code, stuff that could be potentially reusable. And the tools that help you build your project out are essential. As Eli said, back in the day, we didn't have message makers. You had to like write all I mean, the code looked better, but you had to write it yourself. So, and the same concept is there, that you're really communicating between these modules and asking them to do stuff for you. So that's a common thread. Things are clonable inherently, like you can have many copies of the same code, which is useful sometimes. And if you're working as part of a team, both frameworks are really well suited to cleaving projects apart from being a big monolithic, hard to debug thing that one person has to own. Some differences there also?
Yeah. So I guess the learning curve and the required LabVIEW experience is a little bit different. I'm just going to race because I'm ready for a drink. Active Framework is inherited while DQMH is mostly copied, but that makes it more self-sufficient in a way as well. One thing to note that we do have these DQMH broadcasts where in Active Framework we notice that everything is owned by the receiver, where we do have the ability to own a message that goes outbound from a DQMH module. In Active Framework, the top level VI needs to be an actor, and you sort of, this hierarchical design is very essential because whoever launches a module is then completely in control of that module, where DQMH, it's not really a requirement. And you can have a hybrid application where you have some DQMH modules, maybe for a driver within a project, but it doesn't need to be a complete DQMH application, which I like. And obviously, the style is just really different to look at all around. So that brings us to the end of the presentation. It's time to go and have a networking and a few drinks.
Well, you're not going to take questions.
Oh, questions. Nah, questions
You're on your own
that way.
time. Questions on your own time. So we'll stand here for a polite amount of time. If anyone wants to leave, then that's cool.
This is for you. I hope you like Prosecco. It's the best. That was what I was trying to. I love you. Thanks.
So any questions?
I've yeah.
You know, he's holding the microphones at the beginning of the presentation.
So first off, that was awesome. I really liked it. I have lots of thoughts and questions. I'll try to keep it short. What's that?
Stop interrupting him. It's just making it worse.
What's that? Yeah. So I just want to offer. I thought there was. I'm admittedly from an active framework background. I'm still learning DQMH. I have lots of questions and thoughts, including like responsibilities and relationships. I just want to offer a thought, which is something that's crystallized to me the more I learn about both these frameworks is I think they actually do a fantastic job of, like, when I first learned them, for me, like, I started thinking about everything in terms of actors. Like, kind of changed how I conceptualize software and the architecture of software. And I realized it's one of the things that I think many of us feel but don't fully articulate, like, is the unique value of LabVIEW. Like, LabVIEW is used in a domain where we have to interact with the physical world, and we have all these separate, like, lowercase actors in our system, specifically digitizers, hardware, instruments. They're all doing their own thing, and we have this burden more so than most other application software of asynchronously managing how we communicate with them and what we do with the data and how we log that to disk. And so this model of conceptualizing software, I think, is so uniquely valuable in a test domain where you have lots of mixed signals and you're at the constraints of the physical world, which again, a lot of software isn't. And so both these frameworks and workers and these others become, I think, incredibly valuable for this domain because they make it like they take this intrinsic capability of LabVIEW and they allow it to scale in this really, really powerful way. So for me, it's not a question, just a thought. Like it's changed how I think about software, and for me too, it's further crystallized. Like, what is that about LabVIEW that's so uniquely powerful and so uniquely well suited for a domain where you're working with physical stuff? So thank you both. Awesome presentation. I really enjoyed it, and I'll stop myself from asking a bunch of other stuff.
I'll take it away from you. Is there any quick questions, very quick, before we go off for networking?
Yeah, I just want to say the same. I thought that was really good. I actually want to play around with Active Framework now, just to try and see what Chris was doing. Yeah, I thought it was a really good side-by-side comparison, and I've never had that before, so it was a really good example. And it's not about who's better; it's just about this is how you do it. This is how you do it in DQMH. This is how you do it in Active Framework. Peter, are you going to rearrange your presentation tomorrow and do the exact same thing for workers? Because I think that would be even awesome.
Yeah. We'll need 4 hours.
Yeah. So, yeah, well done, guys.
Okay, thanks.
Thank you.